Hello everyone, this is Tommy and it's our group to present on American Airline about the travel experience team for business statistics. With me we have Cairo, Rai, Dean as well as Uma with us today. Yeah, so let's get started. For introduction, we will talk about team, our objective as well as how we get our data set to work on these particular subjects. These are some of the American key facts. They are one of the major United States airlines that headquartered in Texas. So it's also one of the largest airlines on their fleet size, revenue, and sales schedule. Yeah. So this our introduction on these presentations. So most of the time we actually spend most of the time on during the transport or logistic during our trips. We do wait like usually average around 2-3 hours for our flights. So any flight delays will actually affect our whole itinerary, our hotel appointment, or our whole trip might be have to postpone, and this will actually impact a lot during on their experience itself. So in this case, we do our analysis and try to understand what are the really causes on the flight delay, particular on this particular airline, American Airline. So it hopes that it helps airline to improve their service in the future. Let's move on to the data set. We actually use one of the data set from Kaggle. It's called as 2015 Flight Delay and Cancellation. It's provided by the US Department of Transportation. In the dataset itself is a bit confused because it actually includes a lot of information, not just from American Airlines but also other airports and other airlines. So we do use Power Query in Excel to filter out the necessary information and time spent on each activities during the flight sessions. And we also face one of the problems, which is during October, the flight origin and destination, they are actually having some error during data collection where they are using the airport ID instead of the IATA codes identifier, which is usually how we identify the airport itself. I will pass on to Rai to talk about the descriptive analysis.
So we did some descriptive analysis on the data set and we'll shortly introduce the results. Here you can see the number of delayed flights per month, and we can clearly see that most of the delayed flights were during summer season and winter season. But when we look into the average of the delay time per month, it's most of the times equal. Only during this late spring and early summer we can see that the delays are a little bit longer than average. Talking about the daytime of the delays, we have a separated time of the flights for the morning, afternoon and the evening, and we can see that most of the flights are conducted in the afternoon, so most of the delays are also in the afternoon. However, when we analyze the average of the delay, it is pretty much equal in all of the times. Only in the afternoon we have a little bit higher delay average, which is 62 minutes. We also identified that there are several airports which causes most of the delays, and here in this graph you can see top 10 airports which cause the longest delays. Talking about the reason why the delays happen, we have 5 reasons which were mentioned in this data set, which is air system delay, security delay, airline delay, late aircraft delay, and weather delay. By the reason, late aircraft causes most of the delays, together with the airline delay and the weather delay, while the rest has lower impact. But talking about the number, we add the air system delay because it has most of the delays, but probably we can see that those are less longer delays.
Alright everybody, my name is Khairul. I will explain about the statistical inference about the delay itself. So just to recap what Rai has mentioned, so basically in 2015 the American Airlines have around 712,000 flights for the whole year, and then we understand that 252 of the flight with delays, and out that 252 flight delays, 130,000 found to be delays more than 15 minutes. And then the first confidence interval. So we found that about 35% of the American Airlines flight will delay, with 52% of the American Airlines flight anticipated to have delay more than 15 minutes. So first and foremost, we wanted to understand the influence factor that influence the flight delays. So basically, you can see that from the chart above, we can see that the airline delay, late aircraft delay, and also the weather delay have a significant correlation to the arrival delay of a flight from American Airlines. So down below we have the statistical model for this delay, and then we will further analyze on the airline delays, late aircraft delays, and also the effect of the weather. So for the airline delays, with the hypothesis that we established to compare American Airlines against the rest of the other airlines that operated in United States, we found that this airline delay have a Z value is below than the critical Z value. So we can conclude that delay from the readiness to be on time is par as the other airline operating in the same airport. So as you can see, airline delay could be caused by circumstances within the airline's control itself. So it could be from maintenance, crew problem, baggage loading, fueling, cleaning, and etc. etc. So moving on to the late aircraft factor. So what can see that the Z value is more than the critical Z value. So in the sense that we think that American Airlines needs to investigate the root cause of the late aircraft. So the late aircraft is basically a previous flight with the same aircraft arrival late, causing the present flight to be depart late. This could be one of the reason because of this late aircraft is also a factor that under the operator controls. And then the last one is the weather delay. So what we'll see that the Z value of this weather delay is below the critical Z value. So with that, we found that the delay of the American airline due to weather is not significant. It's basically it's par as the other airlines. So basically, what's a weather delay? Weather delay is the significant weather condition that is the judgment of the carrier delays or prevent the operation of a flight, such as tornado, blizzard, and also hurricane. So I will pass to Din to describe about the predictive analytics.
This will be our final parts of our project, which is the predictive analytics. And for this, we are doing a simple linear regression. And the first factor that we analyze is the airline delay. For the airline delay, we compare it against the arrival delay. We found that the R squared is 0.572. This is the highest value compared to the other factors, which shows that there is a strong relationship between airline delay and also the arrival delay. The intercept is at 43.75, which is the lowest, and this shows that airline delay affect arrival delay the most. This support our claims using the R squared. Next is late aircraft. In terms of R squared, it gives us a value of 0.2229, and this also shows that there is quite a strong relationship between late aircraft delay and the arrival delay. The intercept is at 46.28, and this also shows that there is a relationship between them. Finally is the weather delay. The R squared is 0.0216, and this is the lowest R value that we have compared to the others, and it shows that weather delay is the weakest relationship when comparing to the arrival delay. And the intercept is also quite high, which is at 62.91, and that supports our claim that weather delay have the least effect on arrival delay.
Yeah. So after all this, we actually conclude on some of the items here. So we do see a higher delay during the spring session and usually in the afternoons. And for American Airlines, they will need to work with the top 3 airports to work on those delays, because most of them are actually caused by airline delays as well as the late aircraft. So on the item number 3, which is late aircraft, is found to be a significant factors for flight delays, and others factors doesn't really found to be really significant compared to other airlines, which most of the airline also seeing a similar delays. Yeah. So I think that's all for our presentations.